Good afternoon, students. Can you see the screen and can you hear me?
Yes, sir.
Yes, sir. Alright, beautiful. Alright, welcome back after Christmas. The work continues. Can't allow you guys to just not do any work through this period and not only be eating food. You have to eat some maths as well. And so we want to just continue with some revision. We don't want to be doing anything new at this stage. We'll start new content again in January. So we just basically want to just continue the revision of what we have covered so far in the syllabus. And we'll pick up steam again come January. Alright, so I did send this work and we intended to do this last week Tuesday. I was stuck in traffic and was not able to get to a location of the class and in time. So we pick up today. Alright, so I sent two papers, 2017 Ad Maths and 2017 Pure Maths. And I did list a number of questions I want you to do. Alright, so we're gonna work through the Ad Maths questions first. Remember, there are some Ad Maths questions, there's some questions on the Pure Maths paper that are Ad Maths level as well. So we're gonna work through those questions too. So we're gonna get clear the Ad Maths questions on both the Ad Maths paper and the Pure Maths paper, and then we'll do the straight Pure Maths questions and the Pure Maths paper afterwards. But remember, once you're doing Pure Maths, you should be able to do all questions on Ad Maths, especially in the Pure Maths section of the Ad Maths. Alright, so the first question I gave you, well, I can actually just go down the list and see. It was number 1, and this is functions, but the function is not on the Ad Maths syllabus anymore. Alright, it's on the Pure Maths syllabus, and we have not yet covered functions in Pure Maths. But this question, a question like this will not come on Ad Maths anymore. I've saved it for Pure Maths. Alright, that's function. So you won't get something like this in Ad Maths anymore. But part B you will get. It is a remainder factor theorem question, and you can get a question like this, exact same level on an Ad Maths paper and on a Pure Maths paper. Alright, so in this one they give us this function, and they say when it is divided by x plus 1, the remainder is 6. See? Given that the remainder when this function is divided by x plus 1, the remainder is 6. By the way, but you can hear me clearly. Just want to make sure you can hear me clearly. Last time I kept a class in this location, person were saying I was muffled or something. I couldn't hear me clearly. Can you hear me clearly? Because I'm not hearing myself, Can you hear
Yes,
me
sir.
now? Alright,
Yes.
good. And it also says that x minus 2 is a factor. And there are two unknowns there that they want us to determine, A and B. So the A and the B here. Generally speaking, if you have two unknowns, you need two equations to solve simultaneously to find those two unknowns. That's why they're giving us those two pieces of information. First one is that the remainder is 6 when divided by x plus 1. So we have to use the remainder theorem. Alright? So a divisor, the pen is going, oh lordy. Pen is going, I need to get a new pen. Let's see. Alright, so the divisor of x plus 1 lead to a remainder which is equal to 6. What does this mean? This means that f of negative 1 is equal to 6. Or f of negative 1 is the remainder we divide by x plus 1, and that remainder that tells us is 6. So that's one equation we can set up. So we're going to put f of negative 1 equals 6. Right? So it means I want to put negative 1 in this function and equate it to 6. So negative 1 here gives us negative 1 cubed. The negative 1 here is minus negative 1 squared. The negative 1 here is minus a times negative 1. Let's write this better. And then we're adding this b. And that's equal to 6. Just need to simplify this now. So this negative 1 cubed is negative 1 minus this negative 1 squared becomes a positive 1, so it's minus plus 1. And this is negative a times negative 1, that's a positive a, plus b equals 6. Now this is negative 1 and negative 1, that's negative 2. Negative 2 goes on this side, add to the 6 to make it 8. So we end up having a plus b equals 8. And that's one of our equations, right? It's one equation. Let's put it around in a box here and call this equation 1. We're going to get the second equation from that information that x minus 2 is a factor. So we're going to be using the factor theorem now. So we have a factor, x minus 2. They tell us that that's a factor. And from the factor theorem, this means that f of 2 is equal to 0. If x minus 2 is a factor, it means that the remainder is 0, and that remainder f of 2 is equal to 0. That's going to give us our second equation. So again, we're going to plug the 2 in this function here, here, and there, and then put it equal to 0. I'm going to end up with a second equation. So firstly, it is 2 here, so that's 2 cubed minus 2 here becomes 2 squared. Then 2 here becomes minus a times 2 plus b, and that's all equal to 0. That's what this equation becomes. Simplify. This is 8 minus this is 4. This becomes minus 2a plus b equals 0. Let's simplify further. Now this and this is a 4. 8 minus 4 is 4. 4 comes on this side, become a negative 4. So we're left with minus 2a plus b equals, and this 4 comes out on this side and is a negative 4. I'm just basically trying to set it up to look like this one up here. So it doesn't have to be transposed in this exact way. And so we're solving those two equations simultaneously. Right now, if we subtract the two equations, we eliminate the b. Alright, so we're going to use equation 1 minus equation 2. So let's do equation 1 minus equation 2. I have to be careful with these negative signs now. So it's a minus negative 2a. That becomes a plus 2a, which is 3a. A minus negative 2a. When you subtract a negative, you add. So that's 3a. Then b minus b, that gone. Then 8 minus a negative 4. Minus minus again is a plus, so it's 8 plus 4 is 12. It becomes 12. Divided by this 3, we get the a equals 4. And then if a is equal to 4, and the a plus b, if a equals 4 there, then it means that the b is also 4, because 4 plus 4 is 8. So we can say, and the b is also equal to 4. And we can try the answer here as well. If we put a equals 4 there, then we would have minus 2a plus 4 equals negative 4. We should make this negative a to the minus 2. Sorry, is a equals 4. So let's go again. We put 4 right here for the a. That will be minus 8 plus b equals negative 4. This 8 will come over and become a plus b, plus 8, sorry, so b will be 8 minus 4, which is still 4. So anyway, take it, the b is equal to 4. That is correct. So those are your answers right here. Okay, but good at that?
Yes, sir.
Right.
Yes, sir.
Alright, so remember this can be add maths and this can be pure maths, alright? Let's continue. Alright, so part B. It says the values of variables p and x in the table obtained from an experiment are thought to obey this relationship. And this question, as you can see, is going to be writing a relationship in a linear form. This is what it tells us to do here. Use log to reduce the equation to a linear form. And this is a format that CXC specifically says you have to know how to transpose it. They're basically going to use logs. And that linear form that you want is something look like y equals m big X plus c, where this y and this x are functions of the variables, and the variables in this expression are x, small x, and p. So you need functions of small x and p in these two locations. And then now, when you have that, this m is going to be a gradient, and that is going to be your vertical axis intercept. All right, so that's what we have in this question. So let's go. But remember, we're working with x and p. So this p is like a y normally, right? But they give us p, no problem. All right, so the first thing we want us to reduce this into a linear form. So we have to take logs of both sides. All right, it tells us, it says use logs. So we're going to log this side and log this side, log both sides. All right, so when we log the left side, we're going to get the log of p equals log this side, we're going to get the log of ax to the minus k. Now notice I get a small amount of space to work with. So I don't expect many lines of work, and it's only one mark. All right, so what we're going to do is split this now. Log of a product becomes the sum of the logs. So this becomes the log of p equals the log of a plus the log of x to the minus k. We're almost there. Let me shift this over a bit so we can get a little bit more space to work. Divide this line, and we're going to continue up here. Alright, so this now is like our y so far. This is like our c, because there's log of a constant. And what we're going to do is take this minus k and bring it to the front using that law of log, right? Power law. So we're going to get the log of p equals, let's put this term in front, because remember, we're trying to get y equals mx plus c. Alright, so we're going to put this term in front to match there. So I'm going to put the minus k in front. So it's going to become minus k log of x, and then put the log of a last, plus the log of a, log of capital A. So if you compare this with this, you can see that our vertical axis is going to be the log of p. Our horizontal axis is going to be the log of x. Our gradient is going to be minus k, m is minus k. And our vertical axis intercept is going to be the log of e. Alright, that's what we're going to do. So I'm going to write that down here. I'm going to write this is in the form y equals m big X plus c. Alright, and that's what we're going to have. So let's say now, using a suitable scale, plot the best fit line. Plot the best fit line on the equation that we have here on the graph, and use the space to show the workings. So I want us to draw a graph, and the graph is over here. Alright, but we're gonna need log p values against log x values. That's what we're gonna need. Because we have to plot log p against log x in order to get a straight line where the gradient is minus k, and where that line crosses the vertical axis, that's a log of a, the c. Alright, so this is application of the use of a straight line. Alright, so let's go now. So we need log of p values and log x values. So we're gonna put the table down here and write log x, log p. Right, so that's your horizontal axis, that's the vertical axis. Let's make a note. We're gonna be plotting log x against log p. Alright, so we need to work out the log of all these values down here. Alright, that's what we have to do. So let's go. We'll bring up the calculator and work it out, work them out. So we need log of all those values to put in the table. Let's see now. So first we need the log of 1.58. Now that's 0.20 almost, right? So let's say 0.20 if we're using 2 decimal places. So 0.20, and the log of this value next. So let's do all the x values across here first, right? And so we're going to change this inside here to 2.51. That's 0.4. 0.40. So it looks like a friendly scale so far. And this value, that's 3.98. 3.98. That's 0.6. 0.60. And then we have this one next. 6.3. I love 6.3. And that's 0.8 basically. 0.80. And we have this last one out here, 10. But no, log of 10 is 1, right? Log of 10 is 1, see? Log of 10 is 1. That's 1.001. We're going to do the log of these values now, down here. That's what we get. So the first one is the log of this value, 121, 121.5. That's 2.08. 2.08. This is what kind of values we get. Let's go 2 decimal places still. 2.08. And then this one, 110.6. 110.6. That's 2.04. 2.04. And then this one here, that's 106.2. 106.2. That's 2.03. So a little bit off. We have to draw the best fit line anyway. This one next, 99.1. That's 99.1. That looks like about 2.00, right? If you round it off 2 decimal places, you're still gonna get 2.00. And then the last value out here, 93.8. 93.8. And that's 1.97. Alright, so based on this scale, horizontally you can do maybe 1 centimeter to 0.2, and then vertically now you're going to break the graph and start it at 2, and maybe every centimeter you're going to make 0.01, right? Based on these scales, based on that scale. Alright, so also based on the trend of this graph, you can basically look at it. It starts from a high value and it's trending down. You see it going down like this. So you see the values are decreasing. So the negative graph line, as the x values increase, your log p values are decreasing, right? So at 0, you're gonna be up about 2 point. Gonna be about you can just estimate gonna be up about 2 point, add 0.4 to this, 2.12. Maybe it's 0. So you need something going up to 2.12. Right? Because see they don't tell you the scale now, so you have to kind of work it out. Right? You have to kind of work out what the scale. So I'm gonna copy this down. I want to see the graph on this page right here. So I would say I will break my graph down here. Break it. Break it something like this. And start right here at 2. Alright? And then this should be, and look at the scale, it goes up to about 2.1. Oh, sorry, we can't start it at 2. Can maybe start at 1.8 or something like so, as it goes on to 1.9, 1.97. So we're not going to start it at 2. Let's start it at about 1.96. Alright, 1.96, 97, 98, 99, 2. 2.01, 2.02, 2.03, 2.04, 05, 06, 07, 08, 09, 3, something like this, eh? So you kind of gauge it, like kind of test it. So this is 1.06, 1.07, 1.96, 1.97, 98, 1.98, 1.99, 2.0, 2.01, 2.02, 2.03, 2.04, 2.05, 2.06, 2.07, 2.08, that better, 2.09, 2.10. Alright, and then on the x-axis now we can just go 0 0.2, 0 0.4, 0 0.6, 0 0.8, and then 1.0 based on the scale that we have. Alright, based on these values that we have. But the horizontal values, this color going up by 0.2, and based on the vertical values, they're going up like 0.04. 0.04, they're going up by from this to this. It's 0.04. Alright, so that's why you have to do the scale that way. Now to break the scale, you can't start the scale at 0. This is just the lowest value here is 1.97. So you can't start the scale at 0 down here. It won't fit. So to break the scale and start it somewhere here. And as I said, what is important, that's going to intersect the y-axis somewhere up here. So it's going to be okay based on the values. Alright? So it's okay to break the graph and start somewhere down here. Alright, but I understand that? But I understand what I did there? It's something
Yes,
you
sir.
have to practice. Good. You can't start the scale at 0. Start the scale at 0, you're going to run out of graph space. Alright, so let's put on the graphing. Put on the points in red. And you have to do it with a ruler. I'm going to do it free-handed, but you have to do it with a ruler, alright? Alright, so the first one is, well, every interval is 0.2, 0.4, 0.6, 0.8, and 1. So that's okay horizontally. So these values we need to carry down. So I'm going to copy these down. I'm going to copy these. I'm going to copy the table down. Copy these values down. They're in front of us. Let's paste them down here. Let's put them up here. So the first value is 2.08 at 0.2. 2.08. 0.2 here. 2.08 is right here. 2.08. That's right here. So that's a point. Next value is 2.04. So 0.4 is 2.04. 2.04 is right here at 0.4. So we're talking about here. Right? This point right here. Next value is 2.03. That's one a little bit out, but that's alright. 2.03, 2.03 on this line for here. So this one is out, but you still have to draw on this fit line. Alright. The next one is 2.0. Alright, so 2.0 over here, 2.0, 0.8 right here. And every line is going to be different. You just have to work with what you draw. And then the next one will be 1.97, right? So 1 will be 1.97. So this is 1.96, 1.98. This is 1.97 right here, 1.97 right here, and 1. Talking about this point. So those are the points that the line must pass through. So you're going to draw the best fit line through those points. Alright, best fit line through those points. So you use your ruler basically and line it up and draw the best fit line. Alright, you draw the line in black or in purple. So maybe something like this fit line. Alright, something like that. Normally, when you draw a best fit line, though, it's like what they say you must have the same number of points below and as above. I'm having two above here, and so maybe I need to draw it a little bit more in between here. Something like that. When you use a ruler, you know you'll be able to do it. Just use a ruler and you'll be able to do it. So I don't have a ruler to use. Maybe something like that. Alright, maybe something like that. But and another thing what they say about drawing best fit lines as well, they must make as many of the points pass through the line as possible. This one was an outlier, so maybe we can actually just line up these. And you have one of them kind of out of it, right? No, this was the one that was seen to be a bit out. This one. Just check it. This one seemed to be out. But everybody's line gonna be different, right? And they will work with whichever line you draw. But just generally speaking, one, you want to have as many of the points pass through the line that you draw, and two, most times you're trying to get the same number of points above and below the line. So since there was 1, 2, 3, 4, 5 points here, you really want to be passing through 3 of them, and then have 1 above and 1 below. Something like that. Alright, so let me see how we can line that up. So this one was an outer, then kind of straighten up. So like this. Maybe something like that. So say I'm passing through 3 points, I have 1 below and 1 above, about the same distance on either side. So I can work with that line, something looking like that. Alright, you have to do it to the ruler though. And then you extend it back to meet the y-axis. It looks like it's meeting the y-axis right here at 2.10. Let's put on some critical things now. So this will be a C is 2.10. Remember now that C is your log of A is 2.10. Right? And then your gradient of the line, C is the log of E, right? We cross the y-axis, the log of E. And then your gradient is negative K. Gradient is equal to minus K. Alright, so you want us to estimate them, guys. Keyword is estimate. So mean that everybody's answer is not going to be the same, right? Going to have different answers. So the C, let's do the C first. So the C based on the graph is the log of A. And the C is 2.10. So the log of A is 2.10, right? Which is 2.10. So based on that, really working on this here, means that the A is equal to 10 to the log of 2, 10 to the 2.1. Remember, LG means log to base 10. Alright, so the A then is 10 to the 2.10. Alright, and whatever this works out with the calculator, that is your A. Let's work it out over here. 10 to the 2.10. That's 125.89. Alright, that's the A. Then for the K now, we're going for gradient. Now for the gradient, we can use 2 points that the line pass through. Right? Or we can choose to use this y-axis intercept here. Right? So accept that this is the y-axis intercept and maybe this last point down here. Let's assume that pass through this point as well. We can use those points now. This point up here would be 0, 2.10. That's this point. And this point down here will be 1. What is it again? 1.97. And then using these 2 points to calculate the gradient. Right? So gradient from this would be this y value minus this y value divided by this x value minus this x value, which is a run, right? So the gradient m would be 1.97 minus 2.10 over this x value, which is 1, minus this x value, which is 0. That's your gradient to m. And the gradient, remember, is minus k. So it is minus k. Put it up here. The gradient is minus k. So it is minus k. That will be equal to whatever this is. Let's put it over here. I'm just doing it on the screen so you can see. So that's minus k. Maybe I should have done it in red. Doesn't matter. Everybody can see it? Everybody can see this that I'm writing out in black? Can see it? Hello?
Yes, sir.
Alright. So I'm going to do this calculation, that is minus k. So we have a fraction, and that's 1.97 minus 2.1. And divide that by 1 minus 1. 1 minus 0, which is 1. So that's negative 0.13. So the k then is 0.13. So the negatives cancel, right? Basically, this is the calculation that we need up top. This is the calculation that we need up here for the k. So let's make it smaller and put it over here. And that is the calculation for the k. Right? Remembering that the gradient was minus k. Gradient was equal to negative k. That was a nice question. This was a nice one for reduction of an equation to a linear form. This was a nice full one. And that is it. It's not like this, you're going to work it over again. If you didn't do it, you didn't get it, go and work it over again. But that is it. Anybody did it and got these answers, answers close to these? You have to get the exact answers, but close. Close to these. Anybody? Alright, let's assume anybody did it at all.
Sir, somebody said I'm barely hearing you.
So I'm talk about. Alright, you can hear me clearly though.
Yes, sir.
Any better? Person, I can hardly hear him. Any better?
Yes, sir.
Alright, cool. What I was saying is, anybody tried this question? Anybody did this question? I
Yes,
think
sir.
must be this one of 2 times that they set a full linear reduction question like this. We have to actually draw a graph and work out the values. Most times it's just basically might give you something like this. Ask you to write it in a linear form, something like that. Ask you to write in a linear form and then ask you what the gradient would be and what the C would be. Something like that. But this one is a full one. Alright, and you really want to be practicing these full ones. In particular, you want to practice this thing of scaling up the graph in a way that it makes sense based on the values that you have. Right, you have to determine that scale that will work, and don't be afraid to break the scale of the graph like that. Break the scale of the graph, because if you try to fit everything from 0, you will not be able to fit it. Alright, you will not be able to fit it, or you will get points that are so close together. These points will end up so close together that it reduces the accuracy. Alright, it reduces the accuracy. So, what it is that whatever these intervals are from here to here, you want that to be your 1 centimeter on the graph. Right? So the interval from here to here is 0.04. You want 0.04 to be equivalent to 1 centimeter on the graph. Something like that. Or maybe even 2 centimeters on the graph. So the graph is well spaced out. Just remember that. Whatever that interval is between those points, you want that to be equivalent to either 1 or 2 centimeters. And that's like a guide of how you scale your graph. Alright, scaling your graph is very important. And you look at the values and you be smart. This graph starts at 0.97 and goes up to 2.08. If you notice, it is reducing. That's why I did the sketch here. You see that the values are decreasing. So it's a negative graph line. This is 0.2. So you know that at 0, you're going to be another 0.4 above here. Like going up by 0.4, 0.04. You know. So the value above is going to be about 2.12 or 2.10 reach y-axis again. So you need a graph to go from this value all the way up to about 2.12. Right? I would say 2.12. You want the scale for your graph to be from here to here. Something like that. You want to start at that value. Maybe a little bit below this. A little bit below this one. You're not going to have any point going below that. Alright, so watch back the video. Listen to what I've said as a guide to how you plot this graph. Watch back the video and listen to what I've said as a guide of how you decide the scale on the graph. A lot of the times, you have to decide the scale of the graph. They're not going to tell you. You have to decide it yourself. You have to kind of be smart about selecting the scale of your graph. Alright? So that is it. Get a good scale and you get an accurate graph. If the scale is too narrow, points are going to be close to one another and you won't get an accurate line. Alright? It's just going to be jumbled up in one small little spot on the graph. Alright, so remember, whatever this interval is between your points, that's about what you want to be equivalent to 1 centimeter or maybe 2 centimeters. Alright, the wider I can get it to be, the better. Alright, that was that question. Good. Then I also give you this question to do. If you didn't do it, you need to go and do it. You need to go and do it, guys. Go and practice a question like this. We don't know what's coming on the exam. We have not set a question like this in a while. We have to draw the full thing. Anything is possible. Alright, so this question says, they give us this equation. It has roots alpha and beta. And all I want to do is calculate this. And that's a level to which I've been setting it at ADMATS. But we practice higher than this in the class. We practice how to form new equations. Alright? Alright, so this is your equation. Then the A is equal to 2, the B is equal to 6, and the C is equal to 7. The roots are alpha and beta. So you know that the sum of the roots, you're going to need the sum and the product of the roots. So the sum of the roots, which is alpha plus beta, is minus B over A, which you all must know. So that is equal to minus 6, because the B is 6, over A is 2. That's negative 3. And the product of the roots alpha beta is C over A, which is this C over this A. That's 7 over 2 or 3.5. We need to work out these values now. That value. So we have to get this now expressed in terms of the alpha plus beta and the alpha beta. This is basically to make it into one fraction. So 1 over alpha plus 1 over beta becomes equal to a fraction. What does it become? If we take this one and multiply it by beta over beta, take this one and multiply it by alpha over alpha, then the two denominators become the same, alpha beta. And numerator becomes the sum, it becomes alpha plus beta. So this fraction becomes alpha plus beta over alpha beta. And 1 over alpha plus 1 over beta is one of the common expressions that they ask us to find. It's always equal to this. Sum over the product. Alright? More things you know, the better. So this becomes equal to, the sum is negative 3 over the product is 7 over 2. And I'm not going to put 3 over 5. I'm going to put 7 over 2. When you divide by a fraction, this denominator and the fraction can come and multiply the numerator there. It becomes negative 6 over 7. When I take this 2 under here and multiply it up here, it becomes negative 6 over 7. That is the value right there. That's the answer. You put it as decimals and get the answer in decimals, no problem. Still correct. But that is it. Alright, but go to that. Easy question, easy 4 marks. But good?
Yes, sir.
Awesome.
Alright, good. This one now. So determine the range of values of this. Now you have to remember this, guys. Once there's an equal and this inequality, you have to state that this denominator cannot be 0. So you have to state that the denominator cannot be 0. The x plus 1 cannot be 0. So the x cannot be negative 1. You have to be mindful of that. The x cannot be negative 1. Alright? Now, for this inequality, the quotient is greater than 0, which is positive. It means that the product is also greater than 0. Or, we say we multiply both sides of this by the square of the denominator. Why are we multiplying by the square of the denominator and not just the denominator? We have to ensure that we multiply with a positive number. Because if you multiply an inequality by a negative number, you have to reverse the sign. So we are ensuring that we multiply both sides by a positive number. So multiplying both sides by x plus 1 squared. We don't know if x plus 1 is negative. So we square it. We multiply both sides by x plus 1 squared. This side becomes a product. Becomes x plus 1 times 2x plus 3 greater than or equal to, because a positive number this enough, so this sign stays greater than or equal to, and then 0 times anything is still 0. But another way this can be looked at is that if you divide two numbers and the result is positive, then we multiply the two same numbers, the result is still positive. But this can also be 0, that is the problem, it can also be 0. Alright, but the denominator can't be 0, the denominator cannot be 0. So this is like your standard quadratic greater than 0. And if you were to expand it out, you will get a positive square term. Alright? So careful now. This will produce a smile and a graph using a sketch method. Alright, using a sketch method. So we have one root from this will be negative 1, and the other root from this would be negative 3 over 2. You have to realize that the negative 3 over 2 is less than negative 1. The negative 3 over 2 comes on the left side and the negative 1 goes on the right side. Be careful. You cannot put the negative 1 here. Alright? Negative 3 over 2 is less than negative 1. So it goes here. Negative 3 over 2. I'm going to put in negative 1 here. But notice I'm going to leave the circle and the negative 1 unshaded. Why is it unshaded? Because the x can equal negative 1. The x can be negative 3 over 2, so I'm shading the circle and the negative 3 over 2 to tell me that negative 3 over 2 is included. Alright, then now, solution greater than 0 and a smile means that you're looking for values up here on the graph, which are obtained by x values to the right of negative 1 and to the left of negative 3 over 2. So the solution are outside those two roots, not including negative 1. Right? So this is the solution then. Solution. On this end, it is less than or equal to negative 3 over 2. X less than or equal to negative 3 over 2. Or on this side, you cannot include the equal, so it is only x greater than negative 1. Here guys, if you put equal on this, if you put equal on this answer right here, you're not going to get the 4 marks. It's going to be wrong. Cannot put equal on it. Very important. That's the important thing with these rational inequalities. When the equal is included, you have to know that the denominator cannot be 0. Right? The denominator cannot be 0. And that is the answer right there. That is it. That's the answer. Are you okay with that?
Yes, sir.
Good. Down here now. It says an accountant is offered a 5-year contract with an annual increase. The accountant earns a salary of this amount and this amount in third year. Let's go to the third and the 5th year. If the increase follows a geometric series, calculate the amount paid in the first year, that is a A. So we're setting up a GP. That's a GP. In which they are telling us that this is your third term. And the third term is AR squared. The third term is AR squared. And the fifth term is AR to the fourth power. You have to know that. The nth term is AR to the n minus 1 of a GP, right? The nth term of a GP. These things you just have to know. Is AR to the n minus 1. So the third term is AR squared and the fifth term is AR to the fourth power. Now this will be on the formula sheet, you know. We don't have to depend on formula sheet for these things, right? See here, of a GP, the nth term is AR to the n minus 1. Sum to n terms is this. And the sum to infinity is that, provided that the R is a fraction. That's what that means. R is a positive or negative fraction value less than 1, right? In value, or this means the same thing. The value of the R is less than 1, meaning it's a fraction. So they give it that for AP, for a GP, sorry, and they also give it this for a GP, for AP, sorry. Give the n term for AP and the sum to n terms for AP. We don't have to be depending on the formula sheet for these things. They're too easy. Put them in your head. Of time to waste, time to go look for a formula. Just put them in your head and learn it. Practice with them and become second nature to you. Alright, so come back down here now. So basically setting up simultaneous equations. I want us to find the first term. What else I want us to find? The total earned at the end of a contract. Now the end of a contract is, how many years are going for again? 5 years. So at the end of the contract, n equals 5. So we want to need to sum the 5 terms. Basically down here. So down here is asking us for S5. Remember, it's A into 1 minus R to the N over 1 minus R. Or it can be R to the N minus 1 over R minus 1 with the A outside. You can either use this or this, right? Doesn't really matter. We're going 5, we're going N equals 5. That's what this question is asking us for. But up here first, we need to find the, I'm going to need the A down here, right? We're going to need the A. To calculate this, we're going to need the A. Even though they didn't ask us, or they asked us for the A up here, but we need the R, I should say. We're going to need the R down here to put in that formula. Alright, we're going to need the R. Now, one thing I want to point out to you is that these numbers are very large. Because those numbers are very large, you need your R to have a large number of decimal places to increase the accuracy. Alright? You need your R to have a large number of decimal places to increase accuracy of the values because these numbers are very large numbers. Tens of thousands. Alright, so that just comes from experience. But I'm telling you, so you come to class, you can learn the experience that I have. Alright, so we're going to use this for this value and this for this value. Remember, when solving simultaneous equations from a GP, you generally divide. Generally speaking, you divide to solve them. Alright, remember that, you divide to solve them. So we want to equate this third term to this. That's what it is. So we want to have AR squared equals, I'm going to leave out the dollar sign for now, right? 53982.8. We don't need this last zero either when we're talking about money. And the second one is AR to the fourth power equals this figure out here. That is 60598.89. Let's put by the zero on this. Now to simplify this, we're going to divide. We can divide. So we can divide this one by this one. So let's divide them. Divide. So putting this over this. If we put this over this, we're going to get R squared. This divided by this is R squared. The A is going to cancel. And R to the fourth divided by R squared is R squared. Tell me if you see it. We're going to get R squared equals this figure divided by that figure, which is 60598.89 divided by this figure, which is 53982.8. agree with that? Everybody good with that?
Sir.
Alright. Then now, you want A now. So you see this R squared right here, so? Is equal to this figure, you know. Right? So you can literally find the A now, is what they want, by dividing the R squared under here. So you can say the A that we want, this is R squared, you can actually work it out with the calculator form. But to keep it accurate, I can also work with this figure, this expression. Right? So from this equation right here, because it's the A that I want, the first term, you can say the A from this will be equal to 5398.80 divided by R squared, which is this. Alright, so I'm going to write that back on here. 60598.89 over 5398.2.80. We divide by a fraction, this come up here as a numerator, so it becomes the square of that. So it becomes 5398.2.80 squared divided by this figure under here, which is 60598.89. Roll that out to the calculator, and that's the first amount paid. She followed this out over to the left somewhere. But as I said, you could have worked out what this is right here, so write it down and then use it back. Use back that same figure up here for the R squared. But I'm going to show you something about the R, about choosing the R. Let's work out what this exact figure is. Show you the difference if you run based on if you correct your R to 1 decimal place, 2 decimal place, or what. Let me just show you so you can have an appreciation of what I've said. The larger the number is, the more number of decimal places you want the R to be to increase the accuracy. Let me work this out right here. This is the value for A. It's going to be a fraction 5398.2.8 squared over 60,598.89, and that is, I'm going to put the dollar sign on it now. It's the amount 48,089.04. Alright, that's the amount. It's an accurate value for the amount in the first year, the A. It's the most accurate value for the A. Now, what if I worked out the R squared here first? Let's go back and do it now. What if I worked out the go back to 0. Look off the square. That was 8, 9. Look off the square up here. Right, and then we'll do the reciprocal of that. And we'll do the reciprocal of this. 1 divided. Alright, so if you write this out, you get 1.122 or 1.123. That's what it will work out, 1.123 if you work it out, right? If you write this out, you might get this. If you put 3 decimal places, as compared to if you put, let me put a number different to answer a different number decimal. Let me put 1.122559. Let me put that. And I'm saying I would prefer to work with this rather than to work with this. But I think a lot of persons might even work with 1.12. Here so. If you work out the R, right? If you work out the R first, or the R squared first. And that's just R squared, you know. I don't even square root it yet to get the R. That's just R squared right now, you know. I don't even square root it yet. So to get the R, I would have to square root this. So let's say I put the square root over this. Let me get the r this way. Let me not work out the r. So let me work out r. Okay, let's work out r. So r is equal to this. R is equal to this. Let's just work out r. Alright, let's work out r. R is equal to this. I'm going to take out the square and square root this, right? This is just to show you something, guys. So r equals the square root of this. So I'm going to square root this value now. Alright, so don't put the square root over this now. Square root. Put this in a bracket. And square root it. Alright, so this is now r in this case will be 1.059, or some people might put 1.06. So let's put 1.06 to three significant figures as compared to what is now 1.05950 instead. This number is in the 1, 2, 3, 4, 5 digits. See, 5 digits. So I prefer to have 5 or 6 decimal places. 1, 2, 3, 4, 5, 6. Good. So I would prefer to work with this rather than to work with this. Alright, let's check now the accuracy depending on whether we use this one or this one. Remember, this is the accurate answer for A now. Alright. So let's test this now for the A, this one. So the A based on this formula would be equal to 5398.2.80 divided by r squared. Put r on here. R squared. What I'm going to do, I'm going to put 1.06 for the r first. So let's put 1.06 for the r first. I'm going to put 1.06 squared. 1.06 squared. I'm going to write about the same expression. I'm going to show you the importance of the decimal places. Instead of 1.06, I'm going to write out this whole number of decimal places squared. This one that I have in red. 1.059509 squared. Let's work out both of them now. So let's do this one first for the A. It will be a fraction, and it will be 5398.2.8 divided by 1.06 squared. What would I get? I would be getting for this one 48. I'm getting 48,044. So that 0.50. Compare now, this with this. If I use this number as my r, let's see what I would get. So let's change this now and put this figure as my r now. 1.059509. Look what I've gotten. I've gotten 48,089.03904. So that I've gotten an answer that matches that by using a larger number of decimal places on my r. So the point is, when the size of a number is this large, say 5-digit numbers, you want 5 to 6 decimal places on your r in your accuracy. If it's a 2-digit number, then 2 decimal places on the r is good. For a 3-digit number, then 3 decimal places on the r. That's how you kind of choose the accuracy of your r. But understand that for the accuracy of your final result. Understand that, guys? I just use this to show you what the difference would be. But understand that?
Yes, sir.
Alright. So remember this, right? So prefer to work with this r. Use this one for accuracy. That's the point. Alright? Use this one rather than this. You can see it down here. More accurate. The longer decimal place is more accurate, right? Because you're working with very, very large numbers. All right. So let's go down here and calculate the sum. 5 terms, but it was 5 years. And so we'll ask for down here now. Ask for the total salary over the 5 years. The sum to 5 years. So we're working this out. So that would be equal to the sum to 5 years. Would be equal to the A, which is this A. This is the accurate A. That is the A. It should be what is it now? 48089.04 into 1 minus R. Again, we want to be using this R for accuracy. That's what we get. That's what we have to use. 1.059509 to the power 5 over 1 minus 1.059509. Put that in the calculator and work it out. Sum to 5 terms, put the dollar sign in front of it, and that is it. So I'm going to put this in the calculator now. So it's a fraction 48089.04 times bracket 1 minus 1.059509 raised to the power 5 close bracket divided by 1 minus 1.059509, and that's 270. It's 216.77 dollars. That is it. That's the answer right there. It's better. $816.77. That's it. 270,000 for 5 years. What are we good at that?
Yes, sir.
Alright. Good. Alright, did I tell you this one as well? Yes. Go to this one as well. A good number of questions, man. That's good. Alright. This question says a circle has an equation. This is the equation. I want us to express it in this form. Alright. So this, instead of using this, I'm going to use x minus a squared plus y minus b squared equals r squared. In that case, the center is AB. And r is radius. What I want to do is completely scrap these two terms first. Let's write it out. It says x squared plus 4x. And then the y terms, which is y squared minus 2y. And this 20 go over here becomes a plus 20 equals a positive 20. Then complete the square of these two terms. So it's x and half of this value is 2 squared, and you subtract the square of this value, 2 squared. Then these two now is y, half of this is negative 1 squared, and you subtract the square of this value of the 1 actually, and that's equal to 20. Let's remind ourselves of what we do, so practice in class. Half of this value goes here and subtract the square here. So complete the square at this level. Half of the coefficient goes here and subtract the square here. Same thing all the time. And simplify. Right? So this one becomes x plus 2 squared plus y minus 1 squared equals, now this is 4 and this is 1, 5. There's a negative 5. The negative 5 comes on this side, become a plus 5. 5 and 20 is 25. 25 same as 5 squared. So I'm just going to write 5 squared over here. And that is it. That's the equation written in that form. Gotta go to that. That okay?
Yes, sir.
Then it's the state the coordinates of the center and the radius. Remember, this is x plus, so it's like x minus a negative 2 squared plus y minus 1 squared equals 5 squared. So the center is negative 2, 1. Center is negative 2, 1. And the radius is 5 units. 5 units long is the radius. Alright, that is it. 5 units is the radius. Things I want to do, I want a tangent. So determine the point of intersection of this line with the circle. So the circle is this equation, or we can use this original one, or solving it simultaneously with this line down here. Alright, y equals 4 minus x. Alright, so we have to determine which equation I'm going to use to do it. You can just use back this equation, and it doesn't really matter, and solve it simultaneously with this line. Alright, get a point of intersection. We don't have to use this format to do it. We don't have to. So we can come up here. Alright, by the same equation, x squared plus y squared plus 4x minus 2y minus 20 equals 0. Let's copy this down so we can substitute. So to find the point of intersection of this circle and this line, we solve them simultaneously. So we're going to substitute for the y. This is going to come in here for the y, and also go in there for the y. Alright? So at intersection, these y values become 4 minus x. Simple as that. Alright? So at intersection, we have x squared plus this y squared becomes 4 minus x squared plus back this 4x minus 2 times this y becomes 4 minus x minus 20 equals 0, and you're solving that. So this is just x squared here. Expand this out. 4 squared is 16. Then twice the product of the 2 becomes minus 8x. And this term squared becomes plus x squared plus this 4x. Then minus 8. And then minus 2 times minus x is plus 2x. Minus 20 equals 0. Let's consolidate now. X squared and x squared, that's 2x squared. X terms now, that's this, and that. So that's 6x minus 8x, that's negative 2x. That's negative 2x. The numbers now, that's this, and that. Alright, so that's 16 minus 8. 16 minus 8 is 8. And then 8 minus 20 is negative 12. 8 minus 20 is negative 12. Alright? That's negative 12 equals 0. That's the numbers give us that, right? Alright, negative 12. Good. So this can be divided through by 2 at a little bit of space to give us to work. Make this smaller. Go to the left a little bit. Right, so this can be divided through by 2, so then it becomes x squared minus x minus 6 equals 0. This factorizes into x and 2 and 3 and minus and plus. So getting x equal minus 2 and x equals 3 at the point of intersection. Let's put the y values in here now using this equation. Right? Y equals 4 minus x. So at x equal minus 2, y equals 4 minus a negative 2, which is 6. So determine the point. So 1 point is negative 2, 6. Negative 2, 6 is 1 point. And at x equals 3 right here, y equals 4 minus 3, which is 1. So the points are negative 2, 6 and 3, 1. And those are the answers right there. That's it. Sum out these equations for line and a curve basically with substitution. What good with that?
Yes, sir.
Yes, sir.
Beautiful. Beautiful. So it's like an E. Alright. Is there anything else on this paper I wanted to do? I don't think there's anything else on this paper. I don't think so. Let me see. Was there anything else on this paper I told you to do, guys?
No, sir.
Alright, so we're going over to the pure maths paper now. The pure maths paper right here. Alright. Alright, so it was ADMAS students. So you're going to do the ADMAS questions first, right? So you're supposed to do number 1C, 2A, and 4A for ADMAS. And then the pure math students were to do the whole of number 1, 2A, and 2C, and 4A. Alright, so I'm going to do the ones that the ADMAS students were supposed to do first. Each part is a different question. So I'm going to come back and do this for pure math, right? You were supposed to start at 1C. 1C. Right, so that's ADMAS and pure math. This question is ADMAS and pure math. Alright, so it says polynomial, similar to the question that we just did, as a factor of x minus 2 and a remainder of 12 when divided by x plus 2. Show that A is that and B is that. Alright, so this one nice because you know what the answer is. Let's work and get those answers following the same process. So this is a factor. X minus 2 is a factor. So x minus 2 factor. Which means that f of 2 is equal to 0. That's going to give us one equation. So let's substitute 2 in here, and in here, and then put the result equals 0. Alright, let's just go. So 2 in here, so this becomes an 8. So it becomes 8a. 2 in here, so that becomes a 4. 9 4 is 36, so you get plus 36. 2 in here, so it becomes 11 times 2 is 22, so you get minus 22. Plus this b, and that's equal to 0. So this time this becomes, what is that, 14? 36 minus 22 is 14, and it's 8a plus b. So this reduces to 8a plus b plus 14 equals 0. That's one equation. What space we have for our whole page. The next one is that the divisor of x plus 2 gives a remainder which is equal to 12. What does this mean? This means that f of negative 2 is equal to 12. So I plug negative 2 inside here. Result is 12. So let's go again. So negative 2 on the cube right, it becomes a negative 8. So this becomes negative 8a. So it's minus 8a. And then negative 2 here becomes a 4 again. And so we get back at 36 there. So get back at 36. Then negative 2 here, it becomes a plus 22 now. Minus is a plus, it becomes a plus 22. Plus back this b. And then now you're equal to 12. And let's simplify now. So this and this becomes a 58. Alright, and this 12 going to come over here, become a minus 12. 58 minus 12 is 46. 46. So these three numbers are going to come 46 on the left side. 46. So we're going to have minus 8a plus b. I'll say the number become 46 equals 0. So this is our second equation. You don't have to absolutely set out exactly like this, right? Or you know you're solving these two equations simultaneously. Now this is a positive 8a and a minus 8a. If I add them, I'm going to eliminate each other. So I'm going to add these two equations now. 1 plus 2 to eliminate the a. So when we do that, 8a and the minus 8a wipe out each other. The b and the b is 2b. Then we're adding the 14 and the 46. That makes 60. 60. 14 and 46 is 60. So adding 60. And 0 and 0 is 0. So this implies that the b equals negative 30. Okay, transpose the 60 divided by 2. B equals negative 30, which is what they said, right? Good. B equals negative 30. Good. The b equals negative 30, we can take this negative 30 and the b and substitute it back here. So we can say and 8a, when the b goes here, we get a minus 30 plus back this 14 is equal to 0. Now this is negative 16, so we have 8a minus 16 equals 0. Transpose the 16 and divide by the 2, we get a equals 2. So we get the two answers that they have said. So shown. That is it. But I write that. Very good.
Yes,
So
sir.
you can go back over that one more time, please. The last part.
Which part? Down here, sir?
Yes, sir.
All I did, I took the negative 30 and substitute for the b in this equation right here to get this. See that? 8a and the b is negative 30 plus 14 equals 0. See that part? You see that? If you answer
Yes, sir.
no. good. And then the negative 30 plus 14 is negative 16. Transpose the 16, I get 8a equals 16. And divide by the 8, I get a equals 16 over 8. A equals 2. A equals 2. Good? Good now?
Yes, sir.
Alright. Alright, that is it. So you're supposed to do that one. As admans 1c, you're supposed to do 2a. So this, oh, we're not finished yet. You want us to know solve this, right? Solve this. I know the a and the b. We have to solve this now. A equals 2 and the b equals negative 30. So solving the same expression equals 0 now. Same expression equals 0. And what is that? We know one factor is x minus 2. Alright, so solving this. So this equation with a and the b is 2, so it becomes 2x cubed plus 9x squared minus 11x, and the b is negative 30 minus 30 equals 0. Now the x minus 2 is a factor, remember? And solve this by factorizing at this level. So I want to factorize this. So I divide by the x plus 2 factor, the x minus 2 factor. So we're going to divide by the x minus 2 factor. You can divide by the x plus 2 because that is not a factor. So divide by the x minus 2, 2x cubed plus 9x squared minus 11x minus 30. This part is divided. You try to factorize it up, so you divide. So this divided by this first. This first term divided by this first term is 2x squared. That's 2x squared. It's 2x squared times each of these. We're going to get 2x cubed. And then this time this is minus 2x squared. Minus 2x squared. Subtract. Now this minus makes it a plus. As always, the first value is eliminated. This minus makes it a plus. So this is like plus 2 plus 9 is 11. So we're getting 11x squared. These come back down and change because I'm not subtracting anything. So it's minus 11x minus 30. It's this divided by this. That's plus 11x. Then it's 11x times these. You give back the 11x squared and the minus 22x. Alright, and you subtract something wrong. Let's see. Alright, this minus becomes a plus now. Alright, minus becomes a plus. That's 22 minus 11 makes 11. Something wrong. I make a mistake somewhere. Let's see. Make a mistake somewhere. Is x minus 2 as a factor? X plus 2 as a factor. Let's see. X minus 2 as a factor. X minus 2 is a factor. Minus 11. Minus 30, so it is 2. This is the second term. Minus 11x. The b is negative 30. Make a mistake somewhere. So this times this. Oh, it's a mistake here. This is supposed to be a 4. 4. So let's erase these. It's supposed to be a 4. Right here. Right? This time this is 4x squared. 4. Alright, good. So this time this becomes a plus. Alright. That becomes a plus, so that's plus 4 and 9 makes 13. So I get 13x squared minus 11x minus 30. And this divided by this is 13. And 13x times these, giving me 13x squared minus 26x. Subtract, and these are eliminated. This minus makes a plus, so it's like 26 minus 11, that's 15. Alright, so I have 15x right here, minus 30, good. And this divided by this is now 15, and 15 times these gives you the 15x minus the 30 that you're supposed to get, 0. Now, can this be factorized where it is? Can we factorize this where it is? Can that be factorized? Forget the other two factors of this. Now, factors of the 2x squared can only be 2x and x. See, the factors of 15 here and here. It has to be that the far product and the near product add to 13x. Now, factors of the 15. Looks like 5 and 3. 5 and 3. But this and this is 10x. And this is 3x. They add to 13x. So those are correctly positioned. But everything positive. Everything positive. So we need a plus here and a plus there. So these are the three factors of this expression. Alright, so based on that, this equation becomes x minus 2 times 2x plus 3 times x plus 5 equals 0. Those are your factors, their roots. First root is x equals 2. This root, and that factor will get x equals minus 3 over 2. And this factor will get x equals negative 5. Those are your answers right there. Nice question. AdMath students can get a question like this as well. Everybody good with that?
Yes, sir.
Alright, and if you're doing a question and the value is not making any sense, don't make sense to go down in a rabbit hole. As you realize that the value is not heading to where it's supposed to go, check back, make a mistake. Further down the rabbit hole you go, the harder it is to find the mistakes. As soon as you realize that you're going off track, stop and check, as I just did. Alright? Further down you go, the harder it is to find a mistake. I actually gave 9 marks for this. This is the whole question about 9. Yeah, 9 marks for this is part right here. 9 marks for just that part on this paper. Alright. So the next question I wanted to do was 4a. So we are going to come back to this AdMath pure math students, right? But this is not an AdMath, it's proof. 4a is an AdMath. No, 2a. Yeah, this is an AdMath. This is AdMath and pure math. Now, the only difference with this, guys, is that this says ln, which is log to base e. It could have easily have been log lg. So I'm going to work it as if it is lg, since we're doing it for the AdMath students as well. So I'm going to write this as lg. The laws of logs remain the same. Alright, I'm just going to work it with lg. So AdMath students have to follow through and work it with ln. But I'm just using lg since we're in the same class, right? And the L logs with any base, the rules are the same. Alright, so this question says, given that this is equal to that, you have to prove that this expression is equal to that expression. Alright, and this can be done multiple ways. What we can do, we can take the left side and rearrange and transpose until we get the right side, but this must come into play at some point. That's one way. Or we can take this and work towards getting this whole thing from that. Alright, I think I'm gonna, let me see if I can do it in 2 ways for you. And that's one of the things with logs question. Usually it can be done in multiple ways. Alright, usually it can be done in multiple ways. Alright, let me work it as if I'm starting here, and from here I'm going to split this up, and then having split this up, I'm going to take this and work towards that, and then I'm going to do the other way where I take this left side and work towards getting that right side. Alright, let's do it. Alright, so this has a squared plus b squared, and I have a plus b here. But I must realize that a squared plus b squared, just like in alpha squared plus beta squared, is equal to alpha plus beta all squared minus 2 alpha beta. I can do the same thing with this. I'm going to split up this side and write it as that. So the left side here is a plus b squared minus 2ab. That's what this side becomes. The left side is equal to 14ab. And this goes over here and becomes 16ab. So a plus b squared is now equal to 16ab. And when I look, I see a 4 under here. Right? I see a 4 under there. So to get that 4 under there, what I'm going to do is divide by the 16, which is the same as 4 squared. So I'm going to get a plus b squared over the 16 coming under here as 4 squared, because I'm trying to get the 4 under here. That's now equal to the AB that I have. So you have this square divided by this square. I can put 1 square a plus b over the 4 all squared. This can become a plus b over 4 all squared. That's now equal to the AB. And then from here now I can take logs of both sides. Right? So the logs on it, I can now take logs of both sides on this. Right? So I'm going to log the left side and log the right side. So I'm going to log this side and log this side. And put the equal, let me space it out a bit. Equals AB. I'm going to log both sides now. I log both sides. This 2 comes to the front. And this can open up into the sum of 2 logs. So I get 2 log of a plus b over 4 equals the log of a plus the log of b. And I said instead of log could have been ln. Could have took, instead of taking log of both sides, could have taken ln of both sides if I wanted, right? Log of b. Let's multiply both sides by a half now, divide by the 2. So I get the log of a plus b over 4 equals half of all of this side. Half of log of a plus log of b, which what they had right here. I've got it here. Are you good at that? Are you okay?
Yes, sir.
Alright, let's do it another way now. Let's do it another way. I'm now going to be working from this thing. Alright, so watch this now. Bring the proof another way. Bring this over here. So in this method, I'm going to be working from this and try to show that this is equal to that. And as I said, this must come into play at some point, right? Now this has a square on it, and I know that has a square on it. Alright, so watch this now. Prove that this equals that. I'm starting with the left side as this. Left hand side is equal to the log of a plus b over 4. That's the left hand side. Now, because this thing has a square on it, I need this to be squared. Right? I need this to be squared up here, and a square up here. So I can do to get a square up there. I can put the square that I want up there and half it back. Shift this over. So this 2, I'm going to put it up here. But after half it back, it becomes half times that. And I can take this 2 and put it up here. You have to learn these skills. It becomes half and the log of a plus b over 4 all squared. Alright, I take the 2 and I put it up here. That's what is here now. Then now, because I'm trying to generate this, I'm going to now expand this. Expand the 4 as well. Square top and bottom. So it's going to become half times the log. Side this bracket up here, I'm going to get a squared plus 2ab plus b squared over, under here this 4 squared is now 16. See it here now, the a squared plus b squared is 14ab, you know. So this a squared and this b squared add up to 14ab, and the 14ab plus this 2ab give me 16ab on the numerator. I write it out. So the a squared and the b squared is 14ab, this and that. That's what they said. So this thing comes equal to half the log of 2ab right here, and put the 14ab in red fire. So this and this add to 14ab all over 16. Now this becomes 16ab. So it becomes half the log of 16ab over 16. 16's cancel, and so I get half the log of 8 times b. Log of 8 times b is the log of a plus the log of b, which is the right hand side. So I've done it another way, 2 ways. But this step up here is a skill step. You have to learn how to add stuff, add expressions that you want. Right? You have to know how to inject stuff that you want. Mathematics at this level is not only about simplifying. Sometimes it's about building expression rather than simplifying expressions. Because you know what you're working towards. You have a square up here. I need this to become a square. I need to square it. To get a square up here, to put a 2 out here and half it back. Then apply the 2. Is what I did. So stuff like this, you practice and build your skills doing these things. Very good. So it's an OR method over here. OR. The 2 ways. Whichever way you prefer. Anyway you do it, they have to give away your marks. Anyway you decide to go. But okay.
Yes. Yes, sir.
Alright. And I think I also wanted it to do 4a. I think I wanted to do this one too, you know, because this is still 2a. I said 2a. This is a part of 2a. So advanced students should be able to do this as well. This is 2a part 1. This is 2a part 2. So you're supposed to do this too. Advanced students. Alright? So they give us, that's this guy's equation. This negative power means 1 over. Right? So this thing becomes 1 over 2 to the x plus 3 times 2 to the x equals 4. Multiply 2 by 2 to the x now. Multiply 2 by 2 to the x. And this becomes 1 plus 3 times, this becomes 2 to the x squared equals, becomes 4 times 2 to the x. That's a quadratic in 2 days. Let's set it out. So put this as the first term, the squared term is 3 times 2 to the x squared bring this over as a minus 4 times 2 to the x plus this 1 equals 0. That becomes a quadratic into 2x. It's like 3y squared minus 4y plus 1 equals 0. But I'm not going to introduce any y. Let's work with 2 to the x. So I'm going to factorize this. This becomes 3 times 2 to the x, 2 to the x, and you factorize it. Factors of 1 is only 1 and 1. This means that two signs in the bracket are the same, they are both negative. So it's minus, minus, just check it. Far product is 3 times 2 to the x, and the near product is 1 times 2 to the x. Both of them negative, and they add to this minus 4 times 2 to the x. Yes, they do. So it means that this is correct, factorized correctly. So this factor will give you 2 to the x, that's this thing, equals 1 over 3. And this one is 2 to the x equals 1. 2 to the x equals 1. So if you want to get the x out of the power, take logs. So you're going to get log 2 to the x equal the log of 1 over 3. This one kind of easy. If a number raised to a power equals 1, means that the power is 0. Any number raised to the power 0 is 1. If you want to follow through and take logs, you're going to get the log of 2 to the x equals the log of 1. Log of 1 is 0. This x comes to the front, you get x log of 2 equal, but log of 1 is 0. And so the x equals 0 over here, which you could know from up here. Right? Didn't need these steps. For this one, this x comes to the front, so we're going to get x times the log of 2 equals the log of a third. And then divide by log of 2, you get x equals the log of a third over the log of 2. And that is it. Whatever that work out is the answer. Let's say leave the answer out. The response may be expressed in terms of logs. That's what they said. So therefore we don't have to change this. We can leave this as the answer. And leave that as the answer as well. Alright. From right here though, let me show you something. We had 2 to the x equals a third, right? Could have recognized this as, see it here, base power number. Remember, the log of a number to a base is equal to a power. And in this case, it's the power that we want. Right? The power that we want, you know. Oh, sorry. The power that we want. I was showing another way we could have just written the answer down here. So, the power that we want, which is the x, is equal to the log of this number a third raised to this base of 2. So you could have left this as the answer as well. Because this thing is equal to that if you change the base. If you use the change of base law. And so we could have done this as well. Change this to red. But if you do this, you know, you're good enough. If you do this, you're good, right? If you do this, but I just wanted to show you something here. You could have used a relationship. Number base power. That's what we have here, so. Number base power. Power is the log of a number to a base. So the power x is equal to the log of this number to base 2 power x, the log of this number arterial to base 2. So I could have jumped from here to here using that. Right, that is it. But working it out by taking log of both sides, yeah, that works as well. Alright, also wanted you to do, not ready for this yet, wanted it to do 4a, I think I said 4a. 4a. Right here. This again is add maths and pure maths, this one. It says circle C1 has this equation. Circle C2 have a common center. So this and circle T2 have the same center. It says circle C2 passes through this point. Express the equation of C2 in this form. Now, you can know the center on this by observing, by looking, you know. It's half of this and half of this. Right? So, half of this is 2. Alright, if you compute this straight to get the center of this one, let me not shortcut. So when we write this and get the center out of this, so it's x squared minus 4x plus y squared plus 2y minus 2 equals 0. And let's say we're trying to get the center out of this, right? Generally minus half of this and minus half of this, you know. But anyway, let's go. Compute square of these two to be x minus 2 squared and y, subtract, minus the square of this, which is 4. And then y, half of this is plus 1 squared minus the square of this, which is 1, minus back this 2 equals 0. So it's x minus 2 squared, then minus 4 and minus is minus 7, that, you know. So I put back the y plus 1 squared, over the minus, it becomes 7. So the center on this, remember now we're looking for x minus a, we're looking for x minus a squared plus y minus b squared equals the radius squared. So based on that, the center, the a corresponds to 2 and the b corresponds to the negative b corresponds to positive 1, so the b corresponds to negative 1. So the center on this circle is 2, negative 1. But it's the same center on circle 2. But circle 2 also passes through this point. So distance from this center to this point is the radius of circle 2. Radius of circle 2. Right? Radius of circle 2. So can I write here circle 2 radius R2 is the distance between this point and this point, which is square root difference in x squared, that's 2 minus a negative 1. 2 minus a negative 1 squared plus minus 1 minus a negative 2 minus 1 minus a negative 2 squared. Difference in x squared, difference in y squared. This reduces to the square root of, this is 3 squared and this is 1 squared. That becomes a positive 2. 2 minus 1 is 1. That's square root of 10. That's the r on this. R2. So it means that R2 squared is equal to 10. And by the other circle have the same center as this, you know. So C2, the equation of C2 is same as this, just the radius different, you know. Same as this because the same center. X minus 2 squared plus y plus 1 squared equals radius of circle 2 squared is 10. That is it. Radius squared is 10. That is the circle 2 equation right there. What are we good with that? What okay?
Yes, sir.
Alright, good. What is the one? It says the equation of line 1 is this. It says determine whether L1 is a tangent to C1 on page 2. So if it's a tangent, we can use discriminant. It's a tangent. What we can do, we can go to solve them simultaneously. This equation and a circle. And then we'll get our quadratic equation, we can test the b squared minus 4ac. This is a tangent because the b squared minus 4ac is equal to 0. And so we have equal roots, and equal roots means 1 point of contact, one x value. But let's write out the equation first. Equation, this one, circle C1, the one, which was this one, right? This one, copy it down, this same one right here that we have. Circle C1, copy. So I say, guys, discriminant good for you even in pure maths. It was it's really a hard maths topic. So solving simultaneously, so that and the line C1 and the line. So the line you're going to make x a subject. X equals 3 minus 3y. A substitute for the x here and there. Alright? So at the intersection, this x becomes 3 minus 3y squared minus 4 times 3 minus 3y plus this plus y squared plus 2y minus 2 equals 0. I want to see the nature of this equation to know if it's a tangent or not. You have to work it out fully. Right? 7 marks, but we have to work it out fully. So determine if it's a tangent or not. Determine if it's a tangent. This equation has equal roots, then the lines are tangent. Right? As mean that this equation would have equal roots. So let's work this out now. Expand this. We want to get 9 minus 18y plus 9y squared. We get this one, expand that one. So it's first term squared, then this is twice the product of the 2. Multiply these two things first, we get minus 9y, double that to minus 18y. Then the second term squared is that. And this now is minus 12 plus 12y. Because minus minus give you a plus. You have this y squared plus 2y minus 2 equals 0. Consolidate now. This time this is 10y squared. So get 10y squared. The y terms now, that's this, this, and that. So that's 14y minus 18y. 14 minus 18 is negative 4. So that's minus 4y. Minus 4y. The numbers now, this and that are the only one. This stuff are the numbers. So this and this is negative 3. Negative 3 minus negative 3 and minus 2 is negative 5. It's negative 5. That's minus 5 equals 0. Just need to see the nature of the roots of this. We don't have to solve it fully. Now work out the b squared minus 4ac to get the nature of the roots of this equation. Alright. So the b is negative 4 minus 4 times a is 10 and the c is negative 5. This becomes 16 plus some numbers. This is greater than 0, guys. It's never work out, you know. It's not have to work out. That's greater than 0. So you have to work out. This positive and this positive. This is greater than 0. That is real and different roots. So this equation has real and different roots, meaning there are 2 points of contact. And therefore, L1 is not a tangent to C1. But understand that working out? You never ask us for the points, you know, just say determine if it's a tangent. That's all. So even though they give a lot of space and 7 marks, you don't have to work it out. This is good enough right here. Once you get this equation that will give you the roots, you don't have to actually solve it. Just need to find the nature of the roots. What if we were to solve it though? Let's see if we were to solve it. Let me see if we were to factorize. That can factorize. Let's see. So factors of this 5 is all 1 and 5. You know that, right? 1 and 5. Factors of 10 can be 2 and 5. Can factorize, you know, 5y and 2y. It's 25. Or 2y and 5y. No, that will be wrong. 2y and 5. Can't factorize. 1 and 10 don't work either. So that is it. But doing the discriminant, so you see, pure math students, they can get a question we have to use discriminant like this one. Even though they won't ask for the discriminant straight on an odd maths question, on a pure maths question, they will ask the odd maths students. But you have to know the application and times when you can apply. Because they're not asking us for the points, you know. They're asking us to determine if the lines are tangent. If the lines are tangent, then this equation that we get will have to have equal roots, because there'll only be 1 point of contact. So you don't only get one y value from the equation when you solve it. And when you get in only one y value, we call that repeated roots, equal repeated roots. And the discriminant is equal to 0. Once the discriminant is greater than 0, it means that this is giving you 2 different y values for 2 different points of contact. So, and if you have 2 different points of contact, then the line is not a tangent. Alright, you have a circle, you have a line, that's it. It can't be a tangent. Like a tangent or what we call a secant line like that. So a tangent, because a circle we have now, to be like this. Right? It's not like it's a curve where it can be a tangent at one point and then cross at another point like this. That's not what we have. It's a circle we have. Because you can have a curve that's a tangent at one point and cross at another point like that, you know. Like a cubic curve like this one. That's just true. What we have here is a circle and a line. So it's either it intersects at 2 points, don't intersect it at all, or it intersects at 1 point only. Right? Based on this, we're getting 2 different roots. If it never intersected at all, then this discriminant, if this was a case, if this was a situation where you have a circle and the line do intersect, then this discriminant would come out to be less than 0. It means that this equation has no real roots. Right? If it intersected at only 1 point, which means that it would be a tangent, then this discriminant would be equal to 0. In this case, the discriminant is greater than 0, it means that we're getting 2 different points of contact, which means it is not a tangent. Alright. Hope everybody understands that. But to go to that? But alright with that? Explanation?
Yes, sir.
Alright. I'm done with AdMaths now. Done with AdMaths. But you guys can stick around and watch some pure maths. We just have about 3 questions to do with the pure maths to finish up.
Alright, sir.
Who's saying bye? Let me see who's saying bye. We're not going to stick around and learn some stuff. Let me see. Who's saying bye? Luke, you stand by?
No, sir, but I have to go now for real though.
Here, man. I want to see which day you guys stick around and learn some pure maths from now. Anyway, you're learning some pure maths because we just went through some good amount of questions here. Pure maths, pure maths paper, right? That you're learning from. So it's alright. Let's go back up to the top. I'm just going to finish off now with a few questions that are straight pure maths, not add maths at all. Like, for example, this one. Alright, let's go. So this is now pure maths now, straight pure maths. It says, let P and Q be two propositions. P is a proposition, it is raining. Q is a proposition, John is sick. Right? Each statement below in terms of P and Q. It is not raining or John is sick. So it is not raining is not P. This is a symbol for or. And John is sick is Q. That is it. Next one. If it is raining, then John is not sick. If is an if then statement. So if it is raining, that's the P. Implies is an if then statement. John is not sick. That's not Q. P implies not Q. What do go to that? That's a statement. What do go
Yes,
to
sir.
that? Alright. Next one says an operation star is defined on set 1, 2, 3, 4 as shown table below. Alright? So that's star 1, 2, 3, 4. These are your values. And that's this set is closed on this operation because all the values down here are from the set 1, 2, 3, 4. So we can know that. It says determine if it is commutative. Now if it is commutative, then the values are symmetrical across the diagonal. Alright, now this table is not square, so be kind of be careful. So the diagonal is like through here though. That's a diagonal. Now you see the values are symmetrical across the diagonal. So like across here, 4 and 4. Then across here, 1 and 1. Then across here, 2 and 2. And if you extend out is 3 and 3. Everything symmetrical so far. Then across here, as I say, is 1 and 1. And across here is 4 and 4. So I would say yes, it is commutative. Right? So prove that it is commutative. I might choose a couple of values and show. Just to prove, I would say values symmetrical across the diagonal. So values symmetrical across the diagonal such that A star B equals B star A for all A and B which are members of the set 1, 2, 3, 4. So all the pairings A cross B, A star B is equal to B star A. Alright, so if there's an example up here, for example, if you do 2 star 3, I do it this way, 2 star 3, that's equal to this 2. And if we do 3 star 2, if we do 3 star 2, we're still getting this 2. Right? And it goes that way for all the values. Let's go and say prove. You're going to have to write something like that. Right? But the values are symmetrical across the diagonal. It says show that the identity element is 3. So 3, this row matches the top row. Alright? Or this column matches the first column. Alright, so I would say row three equals top row and column 3 equals is what the left row left column. And you can put in all the pairs, right? You can put in all the pairs. You can say 1 star 3 equals 3 star 1 equals 1, right? See there? 3 star 1 equals 1. And do it for all the pairs, all of them. Then 2 star 3 equals 3 star 2 equals 2. And then 3 star 3 equals 3. See there? 3 star 3 equals 3. Let's get them all of them. List all of them. And then 4 star 3 equals 3 star 4 equals 4. That's why it is the identity. And for the identity, when you run the identity and an element, you get by the same element, right? So the identity is such that A star E equals A. That's what happens for the identity when E is the identity. In this case, E equals 3. Alright? I could also write a general statement like this. For all A, which is a member of the set 1, 2, 3, 4, A star 3 is equal to 3 star A equals A. You could also give it to them like this. Instead of listing them out like this, you could have given them a general statement like this. For all A, which are members of set A. A star 3 is equal to 3 star A equals A. That's why 3 is the identity element. That's another reason you could say 3 is the identity element as well. Generally speaking, the identity element is such that A star E is equal to A. In this case, E is equal to 3. Alright, so it could be that way as well. But good? Are you okay?
Yes, sir. Yes, sir.
Alright. That was I think we have the proof now. We have the proof by induction. It's a summation type of proof, right? So this is sum of 8R. So you see the last one is 8N. That's actually the sum of 8R. From R equals 1 to R equals N. So we can say i.e. this is actually the sum from 1 to N of 8R equals 4N into N plus 1, where N is a natural number. That's what we're trying to prove. I'm going to go through the process. Let the statement be Pn such that, and you basically write in this back. Let that be the statement. Alright, put this in a different color up here. Send it with something. Alright. So let Pn be that statement. Remember now there's a 4 steps method, right? Step 1. Prove that it is true for n equals 1. For n equals 1, the left side, which is this, becomes 8 times 1, which is 8. And the right side over here becomes 4 times 1 times 1 plus 1. This is also 8, which means that P1 is true. Then for n equals k, step 2, assume it is true for n equals k, for n equals k. Alright, so this statement, when n is k, becomes the sum from 1 to k of 8r equals 8r equals 4k into k plus 1. Here we assume that pk is true. Step 3 is the work phase, induction phase, for n equals k plus 1. For n equals k plus 1, we end up having the sum from 1 to k plus 1 of 8r is equal to the sum from 1 to k of the same 8r plus the k plus 1 term by adding one more term. So it's the sum from 1 to k plus 1 is sum from 1 to k plus one more term, which is the k plus 1 term, the last term. And the k plus 1 term is always simple when the r equals k plus 1. That's all that it is. R initial equals k plus 1. Alright? What are we supposed to get? What are we supposed to get here, so? When n equals k plus 1. Is what we're supposed to get. The pk is supposed to be, or the pk plus 1, I should say. The pen going, guys. The pen going. Pk plus 1 is supposed to be when this equals k plus 1. N equals k plus 1, right? So we're supposed to get 4 times k plus 1, then this k plus 1 plus 1 becomes k plus 2. We're working towards this. So this whole thing here, so is supposed to become that. So you know what you're working towards, eh? So back to it now. Equals, sum of this is the same from here, so which is 4k into k plus 1 plus the k plus 1 term. We're going to change this into 8 times k plus 1. 8 times k plus 1. Remember, this was the r equals k plus 1 in that. And then now we're supposed to end up with this. Alright? So the first thing we need is the 4 times k plus 1 part of this. 4 times k plus 1. So I'm going to factorize 4 times k plus 1 out of these two terms. Alright? So I'm going to get 4 times k plus 1 out of this, not k times k plus 1, 4 times k plus 1. So this 4 and this k plus 1 come out. So this k gone inside here, so I get the k. If I factorize 4 times k plus 1 out of this, I'm left with a 2. And this 8 is the same as 4 times 2, I'm going to get plus 2. I have it already, now see it there? I have it already, easy. So this can be written out in the form 4 into k plus 1, that's the n, bracket, this k plus 2 is same as k plus 1, that's the n again, plus 1. Here. So it's 4n into n plus 1 we get, when the n is k plus 1. And therefore it has been shown. That is it. Right, this is the n. And therefore pk plus 1 is true if pk is true. And step 4 now you write a conclusion. Therefore, by mathematical induction, original statement of play that we call Pn is true for all n which are natural numbers. And that is a proof right there. Proof by induction. Nice and easy. But alright. Very good. Somebody needs to answer. Nobody answered. Alright, let me assume they're good now. Continue. So we did that, we did that. This is function, we're not going to do this yet. Functions and curve sketching. We're not going to do this yet. We don't do this topic yet. But this one, yes, this one you should be able to do this one. Sum and product of roots of a cubic equation. This one says, given that alpha, beta, and lambda are roots of this equation, notice that there is no square term in it. Form an equation with these roots. Right? Form an equation with these roots. Now, this equation, you must realize that the a equals 1. There's no square term, so the b equals 0. The c equals 3. And the d equals 2. So for this equation, we need to find the sum, which is the alpha plus beta plus lambda equal minus b over a first. And the b is 0, so this is just 0. Then the pairwise product, which is alpha beta plus alpha lambda plus beta lambda is equal to c over a. And the c is 3 and the a is 1, so that becomes 3. And then the product of the three was alpha beta lambda is minus d over a, and that d is 2, so it's minus 2. I don't know, we need the equation with these roots now, an equation with those three roots, right? So if I form a new equation with roots. What are the roots? Alpha beta, let's write them out in that order. Alpha lambda and beta lambda is, as that equation, x cubed minus sx squared plus p2x minus p3 equals 0. Cubic equation, remember, can be written in this format, where s is the sum of these three roots, p2 is a pairwise product of these same three roots, and p3 is the product of these three roots. I want to work them out I'm going to use these to help us work them out. So the s first is some of these three things. S first, some of those three things which we have already. So the s that we need down here, the s, is equal to the sum of these three roots. It's the same pairwise sum here, so pairwise product here, so in the beginning is alpha beta plus alpha lambda plus beta lambda, and that's already equal to 3. So 3 is coming right here. Then the pairwise product of these three roots now. So we're talking about P2 is product of these two first, which is alpha beta times alpha lambda plus the product of this and this, which is alpha beta times beta lambda plus the product of these two now, which is alpha lambda times beta lambda. And let's see what we have now. This works out to alpha beta lambda times alpha. This works out to alpha beta lambda times beta plus this works out to alpha beta lambda times lambda. So if you factorize alpha beta lambda, you're going to get alpha plus beta plus lambda. So it becomes the product of the three roots come up here, so which is negative 2, and the sum of the three roots come up here, so which is 0. So this becomes negative 2 times 0, which works out to be 0. And then P3 now, this is P2. And P3 now is just a product of these three things. Multiply them. So it's alpha beta times alpha lambda times beta lambda, which becomes alpha beta lambda squared. Alpha beta lambda squared. Right? Because it's alpha squared, beta squared, lambda squared. And alpha beta lambda from base is negative 2. Negative 2 squared is 4, so it works out to be 4. 4. So then this equation that we want, put it in a box right here. So run out of space. So this equation that we want becomes alpha cubed. Zoom up. Alpha cubed, and then the sum of the three roots is 3. So get minus 3x squared. The pairwise product right here so is 0. So that gone. You will have no minus P3, where P3 is 4. Minus 4 equals 0. This is the answer right here. That's it. But go to that, like this, cause like it. But okay with this? But go to this? Alexander, you go to this? Tavia, Ramel, Dane. Are you okay? Is me alone in this class?
Oh, yes, sir. Yes, sir. Sorry. Yes, sir.
You don't answer. Alright. I think we're done now. That was what? That was 4C, right? That's 4C. Hold on, let me see. So I gave it to the. No, that was 2C. I did 4A. I think that finishes it, for today. I don't know what I gave it to though. Because I think the rest of it is tricks. I did the 4 already. That we're supposed to do down here. 4A. Alright, that's it. That's it, guys. I'm gonna give you some work again on Tuesday. Some more practice for Tuesday's class. Another paper, another set of papers. Add maths and pure maths. Either I give them to you to do for Tuesday and work them out Tuesday. I don't think we're having in the class Friday. Friday is what date? That's what date Friday is.
Yes, sir.
Huh? Friday is on the 2nd. I think we can have a class on the 2nd. Let's see. Thursday the 1st. Let me see. Okay, Thursday the 1st. So Friday the 2nd. We can have a class on the 2nd. But Tuesday. Today is Sunday. Yeah, we can have a class on Tuesday. Alright, I'll decide what we're doing, alright? Just need to keep the revision going. So I'll decide and let you know. So I'll give you some work to do. I'll work them out Friday or vice versa. But we work out something and I'll let you know. But we just have to keep practicing. Alright, so the questions sometimes I'm gonna send the video in the group. And you guys just redo the questions. Go back over anything you got wrong, anything you didn't understand. Go back at the questions and so on. Let's keep the revision going, alright? Going on to new material in January for both Add Maths and Pure Maths. Alright guys, that's it for today. See you on Tuesday online. Bye everybody.